D correct option, because that when you extend, it will cut y-axis on negative quadrant. Next row. What is E in Einstein equation h nu minus w0? What is E in this equation? Maximum kinetic energy of photoelectron. So option D. 34. Photo threshold is mu 0 when light of frequency 5 nu 0 is incident. The frequency of the maximum kinetic energy of photoelectrons will be K E max is h nu minus h nu 0. H into 5 nu 0 minus h nu 0. 4 h nu 0 is the maximum kinetic energy. Option 34. Two metals M1 M2 has work function of 5.1 electron volt and 1.7 electron volt respectively. The light of wavelength 3310 angstrom is incident on two metals. Which of the following statement is correct? Only M1 will emit, only M2 will emit, both will emit, none of these will emit. See, if energy of light incident is greater than work function, then it will emit. So I am finding what is energy of photon. It is h c by lambda in joule. I am dividing by E, it will become electron volt. Hc upon E has got constant value 12.43 into 10 raised to minus 7 upon lambda 3.310 into 10 raised to minus 7. 3 4s are 12, 3 1s are 3, remainder 1, 3 4s are 12. So this becomes 4.14 electron volt is energy of light incident. Is it greater than both M1 M2 or only M1 or only M2? E is greater than M2, hence M2 will emit. Clear? M1 can't emit because its work function is greater than that of energy of light incident. Have you completed? 34? Completed? Sum number 34?
Yes, sir.
Photoelectric work function for metal surface is 4.125 micron. The cutoff wavelength means threshold wavelength is how much? Work function is hc by lambda 0. I'm dividing by E to convert it in. And I told this value, please remember. This is 12.43 into 10 raised to minus 7 upon lambda 0. So lambda 0 is 12.43 into 10 raised to minus 7 upon 4.125. So this is nearly 3 into 10 raised to minus 7 meter. So approximately 3000 Newton. Approximately 3000 is given in option. So all sums you can do faster if you remember this HC upon E value. 12.43 into 10 raised to minus 7. Okay. Ishika, completed?
Sir.
Threshold wavelength for metal having work function W0 is lambda. What is threshold if work function is 2 work W0? So work function is Hc by lambda 0. Work function of first upon second is wavelength of second upon first. So W0 upon 2W0 is second threshold upon lambda. Lambda by 2 is threshold. Lambda by 2. If you complete, tell her so that I can go to the next one. Done? Yes, completed. 36.
Yes, sir.
Work function of a metal is 4 electron volt for the emission of photoelectron of zero velocity. For emission of zero velocity, wavelength must be threshold. So what should be that wavelength, which is just giving zero velocity, is called threshold. Hc upon lambda 0 divided by E electron volt. 4 equals to 12.43 into 10 raised to minus 7 upon lambda 0. Therefore, lambda 0 is 12.43 into 10 raised to minus 7 upon 4. 4 3s are 12. 4 3s are 12. 4 into 1 4 into 10 raised to minus 7. So approximately 3100 angstrom. 3100 angstrom options.
हो गया सर.
The maximum velocity of light of wavelength lambda incident on the surface of work function phi will be. So K B max is hc by lambda minus work function phi half m v maximum square hc by lambda minus phi. So V maximum square is 2 by m times hc by lambda minus phi. So V maximum is 2 by m hc minus lambda phi upon lambda whole raised to half. M lambda 2 hc minus lambda phi raised to half. A photon of energy 8 electron volt is incident on metal surface of frequency 1.6 into, make it 10 raised to plus 15 hertz, 1.6 into 10 raised to 15 hertz. Then kinetic energy of the photoelectrons will be how much? In electron volt, take H as 6 into 10 raised to minus 34 joules. So if I find work functions given and a photon of energy 8 nu is incident on metal surface of threshold frequency. So if I find threshold from threshold frequency work function in electron volt, then energy minus work function is called kinetic energy. Formula for work function is h nu. If I divide by E, it will become in electron volt. Work function is h nu 0 divided by E becomes in electron volt. 6 into 10 raised to minus 34, 1.6 into 10 raised to 15, 1.6 into 10 raised to minus 19. So this will be equals to 6 electron volt. Now Ke is energy minus work function. 8 minus 6 equals to 2 electron. Okay, 39. Yes, 39.
हाँ sir.
For a certain metal, the threshold is mu 0. If the light of frequency 2 nu 0 is incident, Then electron coming out is as velocity 4. If the frequency is made 5 nu 0, then maximum velocity of electron. So K max I can write half m V maximum square, which is h nu minus h max. So taking ratio, this will become V1 square upon V2 square is h into first is given as first frequency is 2 nu 0 minus h nu 0. Second is 5h nu 0 minus h nu 0. So 1 h nu 0 upon 4 times h nu 0 will become 1 by 4. So taking square root, V1 upon V2 is half. Therefore V2 is 2 times V1, which is 2 into 4 into 10 raised to 6. 8 into 10 raised to 6 meter per second. Option. Okay.
Yes, sir.
Threshold wavelength. Threshold wavelength for photoelectric emission is 5200. Threshold emission is 5000. That means this is in visible range. Photoelectrons will be emitted when material is illuminated by monochromatic radiation from there. So for emission, we should have less than visible range. Gamma, X-ray, UV, visible, infra, this is series. So less than this means it can be ultraviolet, it can be X-rays, it can be gamma, but not infrared. So B option will be the emission. Light of two different frequencies whose photon have energy 1 electron volt and 2.5 electron volt. Work function 0.5 electron volt. Work function 0.5 electron volt. Then ratio of the maximum speed. Ratio of maximum speed directly we can say V1 square upon V2 square is E1 minus work function upon E2 minus work function. So V1 square upon V2 square is 1 minus 0.5 upon 2.5 minus 1. So V1 upon V2 square is 0.5 upon 2 It is 1 by 4. So ratio will be 1 by 2 option.
Done, sir.
The slope of stopping potential slope of stopping potential versus frequency. Now to recollect, slope of stopping potential versus frequency is h by t. This option. The stopping potential is the function of the frequency. Which one represents? Then the graph shows that work function of A is greater than no. Work function of A is smaller than work function of B because B intercept is greater as compared to maximum kinetic energy when photon of energy 6 electron volt is incident on it is 4 electron volt. Then what is stopping potential? See, we know formula kinetic energy is E into V in joules. But kinetic energy, if you divide by E, it becomes electron volt. So in this case, I can cancel it. So you can remember kinetic energy in electron volt is actually stopping potential in volt. Is stopping potential in volts. That means directly you can say 4 volt is the stopping potential. No need to calculate. Just keep it up. sixth. A light of wavelength 300 nanometer is incident on photoelectric emitter. Photoelectrons are liberated. So this is threshold. For another emitter, however, when 600 nanometer is incident, it creates sufficient photo emission. What is ratio of work function of first to that of second? So reciprocal of wavelength is work function. It is 600 upon 300. So ratio of first to second will be 3:47. The number of ejected photoelectron increases with increase in number of photoelectron emitted increases with increase in intensity. P47 done. In photoemissive cell with exciting wavelength lambda, the fastest electron has velocity v. That means when wavelength incident is lambda, then v maximum is v. If it is changed to 3 lambda by 4, then v maximum relation will be how much? The speed of fastest emitted electron will be how much? Half Ke max, we all know it is hc by lambda minus work function. So in first case it is hc by lambda. Ke max in second case is hc 3 lambda by 4 minus work function, which will be 4 by 3 hc by lambda minus work function. That is second kinetic energy. We are interested in relation between speed. So I am converting this in terms of kinetic energy of first one. hc by lambda, you can say Ke of first one plus one function minus this one. So this becomes 4 by 3 Ke1 plus 4 by 3 work function minus work function. That will become Ke2 is 4 by 3 Ke1 plus 1/3 of work function. So if you see carefully, Ke2 is greater than Ke1. Ke2 becomes greater than Ke1. Therefore, Ke2 is greater than 4 by 3 times Ke1. Therefore, half m v2 square is greater than 4 by 3 half m v1 square. Half we can cancel m and v2. So v2 is greater than 4 by 3 raised to half of v. Very important, sir, because if you don't start properly, you lose the link of this numerical. So it is C. Once you complete 10, so that we can start next. हाँ मैडम, हाँ tomorrow, right? No problem. हाँ no problem. ठीक है, no problem. No, no problem. No, today evening also if you wish you can write, no problem. Okay. So, the maths you can write tomorrow. No problem, let him write tomorrow. No, no issue, no issue. No problem, madam, no problem. Let him write. Thank you. Thanks a lot. Thanks. Thanks a lot. Thank you. Thank you. Thank you. Is completed? Hello? Completed till 48?
Yes, sir.
Photoelectric cell converts light energy into electrical energy. Light energy to light. No. See, unfortunately, there are two options. You can mark anyone. BD both are correct as per this. So, yeah. In photoelectric effect shows the variation of cutoff. Cutoff means stopping potential with frequency. As which one is correct option? C is the correct option. C is correct option. But still time is there. Atoms, molecule, nuclei will start. This PDF also I think I have sent you. Atoms, molecule, nuclei. Hello, you all have this PDF of atoms, molecule, nuclei?
Yes, sir.
Yeah. Open page number 12 of atoms, molecule, nuclei. You open page number 12. Hello.
Yes, sir.
According to Rutherford atomic model, electron revolving around the nucleus is a line spectrum, band spectrum, or continuous spectrum. See, Rutherford said the accelerating electron continuously radiates energy. So, as per him, it is continuous emission spectrum. B option. Second, postulate of quantized angular momentum leads to maximum Planck to estimate value of celebrated constant h. So by second postulate we get MBR is quantized of h upon 2 pi, therefore d is correct answer. The angular speed of electron in an orbit, see v, is inversely proportional to n and r is proportional to n square. Omega is v by r, so it is 1 upon n into 1 upon n square, 1 upon n. Inversely proportional to n cube option. Next, radius of atom in ground state means first orbit is 5.3 into 10 raised to minus 11 meter. After collision with electron, it has found to be the radius of 21.2 into 10 raised to minus 11 meter. The principal quantum number n of the final state atom is. Now, r of nth orbit is proportional to n square. So, first orbit to nth orbit, I can say 1 upon n the whole square. So, first one is 5.3 into 10 raised to minus 11. 21.2 into 10 raised to minus 11 is 1 upon n square. 5.3 into 4. So 1 upon 2 is 1 by n. Therefore, n equal to 2. So it is second order. N equal to 2. Completed? Yes, completed first four.
Yes, sir.
Yes, sir.
Next. Area of electron orbit for the ground state of hydrogen atom is A. So area of electron orbit corresponding to first excited state. First excited state means second orbit. First excited state means second orbit. So area of orbit, nth orbit, is proportional to r square, which is n square raised to 2. That means n raised to 4. So So first orbit upon second orbit is 1 upon 2 raised to 4. So A2 will be 16 times A. That is next. In Bohr's model of hydrogen atom, radius first Bohr's orbit of hydrogen lies 15.3.1 into 10 raised to minus 12 meter. First Bohr orbit lies this much from the nucleus. So this is radius. Centripetal acceleration of the electron will be how much? Centripetal acceleration is v square by r. First orbit's v you have to remember. It is 2.189 into 10 raised to 6 upon 53.1 into 10 raised to minus 12. So this I can write roughly 2.2 square into 10 raised to 12 upon 53.1 into 10 raised to minus 12. So 4.84 into 10 raised to 24. This is 53.1. So you can take approximately, this is 5. Approximately if I take 5, this is 50 into 10 raised to 24. 1 by 10, so 0.1 t. 0.1 into 10 raised to 24, 1 into 10 raised to 23, which you can write 9, 10 into 10 raised to 22. So C we can write option. 1 into 10 raised to 22 is 10 into 10 raised to 22. Therefore option C. Completed?
Yes, sir.
Seventh one. Total energy of electron orbiting around the nucleus in ground state is minus, ground state means first orbit, is minus 13.6 electron volts. So A, negative less than 0. Energy in the lowest orbit means first is minus 13.6. What will be the energy from fourth to second orbit when electron transit or jumps? So I told you please by heart all the 5 value of energy. First orbit energy is minus 13.6. Second orbit is minus 3.4. Third orbit is minus 1.51. Fourth orbit is minus 0.85. So minus 0.85 minus of minus 3.4. So it will become 3.4 minus 0.85. 10 minus 5 is 5. 13 minus 9, 5. 2.55 electron volt. 2.55 electron volt option.
लिख लिया सर.
Next one. Right. Energy of electron E is given by formula minus 13.6 upon n square. So energy of photon ejected when it jumps from third orbit to second, same concept. This is minus 1.51 minus of minus 3.4. So plus 3.4 minus 1.53. 10 minus 7, 3 is 7. This will become 13 minus 5, 8. 1.87 electron volt, which we can round off as 1.9 electron volt option. Done. 10th one. When hydrogen atom is raised from ground state to the fifth state. From ground state to the fifth state, that means height is increased. So I can say potential energy will increase. And kinetic energy will decrease. That is option 11th. The orbital velocity of electron in ground state is v. Its orbital velocity when excited to the 1.51. Since minus 1.51 electron volt means which orbit it is? Third orbit. Therefore, V3 we have to find. So V is inversely proportional to N. So V1 upon V3 will become 3 by 1. Therefore, V3 is V by 3. Completed? 11th?
Yes, sir.
So that's all for today. Next, we can have lecture on